Assalamu alaikum friends, my name is Bilal Khan and this is my 27th video of DevOps. So in this video I am going to talk about jobs, init containers and pod lifecycle. So the first thing that I am going to talk about is the jobs. So job is another object of the Kubernetes, but its purpose is different from pod. Alright, so we have replica sets, diamond sets and deployment etc. They all share one common property. They always make sure that the pod is running. The controller restarts or reschedules the pod to make sure that the application in a pod always keeps running. Alright, so in the pod we have discussed in the previous video that they will create a replica set, and after creating the replica set, the pod will make a copy of it if it is deleted. Alright, so the pod will be recreated again. But there is the job, in case of jobs, the copy of the job will not be created. Alright, so if the work is completed of the job, it will be deleted and the further copy of the job will not be created. So there is another object that is called jobs. It is not bound to be running every time. Instead, if the task is completed, the jobs will stop. Alright, the pod can be recreated again if required, but the jobs will not will stop if the work is finished. Alright, so you can schedule it and it will be created and deleted multiple times. So the thing that you can do with the jobs to be created and deleted multiple times is to schedule the jobs multiple times so that it can be created and deleted. Alright, so here is an example of the job. This is the YAML file. So I'm going to show you, so as you can see, that this is the API version v1, batch v1. This is the kind of job. Inside this job, this is my job name, and this is the label, metadata, inside the metadata, the template, and these are the specifications. Container name is C01, the image is sent to S7, and the command is bin bash echo Bilal Khan. Alright, so it will print the Bilal Khan, and after that it will sleep for it will take the 5 seconds. After 5 seconds the container will stop, alright, and it will not delete the job. Alright, the container will stop, but it will not delete the job. Instead, you have to delete the job yourself by writing kubectl delete job and the job name. So this is not the correct point. I will have to delete this, but if you want to delete the job, you have to delete it by running kubectl delete -f and the file name. Alright, so let's apply this file, and let's first of all come into the terminal and write ls. As you can see that I have already created a file by the name of jobs.yml. So if we take a look, jobs.yml, as you can see that this is the template that I have shown you here. But the difference is there that I have give the sleep time 20. Alright, so you can give it any sleep time, but I have given it 20. So the restart policy, I have forgotten to show you that the restart policy is never, that the jobs will never run, alright, if it is deleted. So let's clear it, and after that let's start Minikube first of all, and after that I will apply the jobs.yml file. So let's wait for it. It will take me some time. As you can see that the kubectl is now configured. Now what I have to do is to write kubectl get pods. Alright, so no resource found. Why? Kubectl watch get pods. No resource found here. Alright, so I have not applied this file. Sorry, I have forgotten. Kubectl apply and then jobs.yml, and after applying this I will write kubectl get pods. As you can see that it is giving me the ready state 101 because it is the container is not deleted yet, but after some seconds, after a few seconds, as you see, it is still giving me after 15 seconds, but if I write it again 20 seconds, it is still giving me 101. Let's take a look at this. As you can see that now the 23 seconds are passed, but it is showing me the ready state 001. Why? Because the container is now deleted. Alright, but the job is still present. If I take a look, as you can see that 30 7 seconds are passed and the status is completed because the job is deleted, sorry. The container is deleted but the job is present. If I write kubectl get ports, you will see the time is passing and the container is deleted from this job, but the job is present here. Alright, so let's clear this, Control C, and after that let's take a look at the parallelism. If you want to delete a file of the job, you can do this. So let's take a look at kubectl delete -f by force and then jobs.yaml. You will see that now the jobs will be deleted. No resource found in the default namespace. Alright. So now let's take a look at the parallelism. It will create multiple pods and run them parallelly and delete them after some given time. Alright. Although this is also the kind of job, but instead of creating one pod, it will create multiple pods and they will be run parallelly at the same time. Alright, and after that they will be deleted after some given time if it is mentioned. So as you can see that I have mentioned the 30-second here, and the five pods are running at the same time parallelly, and this is the active deadline seconds. So basically the 30 seconds will take to delete a container, and after that the 10 seconds will after 30 seconds the 10 more seconds will take to delete a pod. Alright, so combined it will take 40 seconds, 30 seconds for deleting the container, and 10 more seconds will take for deleting the pod. Alright, so as you can see, the parallelism 5 will run 5 pods parallelly. Sleep 30 will terminate the containers after 30 seconds, and active deadline seconds 10 will delete the pods after 40 seconds. The container will be deleted after 30 seconds, and after 10 seconds of container deletion, the pods will also be deleted. Alright, so after applying it, if you type watch kubectl port get pods, you will see that all the pods are deleted after 40 seconds. So let's copy this, and after copying it, let's write vi parallel. Alright, parallel.yml. So press I and then paste this and press escape wq, sorry. And as you can see that now the parallel .yml file contains the data. Alright, so now let's apply this kubectl apply f and then write a parallel or yml. So now this is applied kubectl, watch kubectl get pods. As you can see, there is no, 30 seconds are passing. So as you can see that these are 5 pods that are created, and it is giving me the ready state one by one. Why? Because the containers are not deleted yet, because 30 seconds has not passed. So 27 seconds, 29 seconds, and 31. So it will take me some time, because alright, as you can see that all the data are deleted. Alright, after 30 seconds, because it has taken more than 30 seconds to delete the pods, because it took some second more to start. Alright, so it took some more seconds to start. That's why it is taking some more seconds to delete. But the result is that all the pods are deleted after 30 seconds. So this is working fine. If I write kubectl get pods, you will see that there is no resource found. Alright, so this is working fine. And after that, the next point is the cronjob. So basically, as you can see in this file, this is also a kind of job, but I have written the cronjob here. This is the name of the kind of the job, and this is the schedule. So basically, these stars mention 1 minute. One star mention 1 minute. Similarly, this star mention 1 minute, and this star. So there are 5 minutes. It is mentioning. This is the job template. Inside this job template, there is a specification template, specification containers. Ubuntu name is Bilal. Command is this Bilal Khan, and after that, restart policy never. So basically, these stars in the schedule shows the minutes. Each star represents 1 minute. Alright, it means that the new pod will be created after every 1 minute. Alright, so every 1 minute it will create a new pod, and the container inside the pod will be terminated after 5 seconds. Alright, so after 5 seconds the container will be terminated, but it will take me 1 minute to create a pod. Alright, so after applying this, watch kubectl, and you will see that the pod is created after every 1 minute, and from 0 to 5 seconds the ready state will be equal to 101, but after 5 seconds the ready state will be equal to 0/1. It means that the container is deleted after 5 seconds. So I will copy this template, and after copying it I will simply write vi and write cron.yml. So let's write I, and after I press paste the data, and let me change this sleep time from 5 to 30 seconds, because I will have to write the kubectl get pods, so that's why it will take me some time to write the commands. So that's why I have increased the time here also. So let's escape this wq, and after that let's apply this. First kubectl apply f, and then cron.yml. So cron.yml, no mention cronjob in the version. Alright, batch 1. Sorry, this is the error that it is showing me. And now I write kubectl get pods. Alright, so it is still not showing me anything. Why? Because there is no, it will take 1 minute to create a job. So let's wait for it. As you can see that this has taken some time to create 1 minute to create a job. So after that, after 30 seconds, this job will be deleted. Alright, so it is showing me 1/1, but after 30 seconds or more seconds, more than 30 seconds, it will delete this job, and a new pod will be created. 30 seconds, 32, 34. Alright, as you can see that it is 0/1. Now this pod container inside this pod is deleted, so it is showing me this pod name, but the container inside it is deleted. So now it will take me another 1 minute to create a new pod. Alright, as you can see that another container is creating inside this pod. It is running. Alright, so it is also taking it will also take 30 seconds to run this, to delete this container inside this pod. So let's wait for it. Now you can see that the container inside this pod is also deleted. So this process will go on until it reaches to 5 minutes, because there are 5 stars present here. So let's delete this, clear this, and after that clear this. Alright, so now let's move to the init containers. So what is init container? So init container is an initialized or the starting container that will run and is required before running the main container. Alright, so the init container is the initialization. Before starting the main container, the init container will start, so that it fulfills the requirement of the main container. So let's say, take an example. Let's say that the main container is an application. Alright, but the init container is the process to first install that application or log in and run that application in the main container. Alright, before starting an application, you will have to first install it, and then you will have to log in or sign up into that application, and then you will be given an access to the main application. So the init container will perform this kind of functionality. So you can process in init container, alright, before creating the main container. Alright, before creating the main container, you will have to specify the processes, that what are the things that are required before running the main container. When the main container is created, the init container will be deleted. Alright, so because the work is finished, the init container work is finished, so the main container is now running. So the work of the main container, init container is finished, so it will be deleted. If the init container fails, then the Kubernetes will repeatedly create it again until it is succeeded. Alright, because without the init container, the main not run. So it is required for the Kubernetes to run this init container multiple times, so that if this init container is succeeded to run, then the main container will run after this. Alright, so here are the use cases of it. Make a format of the database before installing the values in it. Alright, so if you want to install the values in the database, you will have to first format the database. So this is the init container to format the database before inserting the values in it. Delete to launch until the dependencies are ready. So you will have to first ready the dependencies, install the dependencies, and then the application will launch. So dependencies are the init containers. Clone the Git repository into the volume to get the necessary files. So if you want to get the necessary files, you will have to first clone the repository, Git repository. So the Git repository in this case is the init container. So let's take a look at this example. Let's copy it. All right. And after that, first of all, let me show you what this will do. Sorry. So this is the kind of port. This is the init container name. Inside this init container, there is a container. The container 1, the container 2. So this is the init container, and this is the main container. Alright, so the image is sent to us. It will basically give me a message, like and subscribe, Bilal Khan, and after 30 seconds, this message will be printed in the main container. Alright, and the container is C2 sent to us. Alright, sleep down 5 seconds, done. Alright, and as you can see that the mount path is exchanged, so the data will be present inside the mount path exchange, but the main container data will be present inside the data directory. Alright, so after this main container will run, after this init container runs, then after that the main container will run. Alright, so it will print the data, the main container will print the data of the init container. Alright, so first you will have to run the init container. So let me show you an example of it. So let's make another file, vi init, alright, YAML. So as you can see, if you press I, paste this data. Let's increase the time of it from 5 seconds to 20 seconds. Let's take it 20 seconds. Alright, and after that press escape, WQ, and after that it will show you initializing. Alright, so if the init container is run, then it will show me that the port that it will give me the ready state. First of all, it will give me this ready 0/1 init, because the init container will first initialize, and then after that the main container will run by showing me this message 1/1. So let's write kubectl apply init.yaml, and if you write watch kubectl get ports, you will see that this is giving me the initialization, and that the init container is not created yet. So if it give me 1/1 after after 30 seconds, if it gave me after 30 seconds 1/1, this means that the container is now running. So let's wait for it. As you can see, sorry, these are containers are already running, so no problem. Alright, so init container 1, pod initializing. Alright, so now the pod is initialized and the container is running here. Alright, so this is working fine. And after that, let's write this command, pod name. So let's close it and write pod name. So what is the pod name? kubectl get pod init container. Alright, so let's get the pod name here. Sorry. I've forgotten this command to write. So let's kubectl logs f pods, pod name is init container. So sorry, I have written the log kubectl command properly. As you can see that it is giving me the like and subscribe Bilal Khan. So let's wait for 30 seconds, and now after that it will give me another message again that like and subscribe Bilal Khan. So currently there are 4 these messages. As you can see that after 30 seconds the new container is started and it is giving me the like and Bilal subscribe message again. So let's wait for another 30 seconds. As you can see that this like and subscribe message is giving me again. So let's clear this, and after that let's write kubectl get pods. As you can see that these are the containers that are running. So if I want to delete this, how can I do this? I will simply write kubectl delete. So now pods also. First of all, let's delete this, and it will take me some time. So let's open another type, kubectl delete f cron dot yaml. So it is the Bilal is also going to be deleted. This is deleted. Alright. So let's write kubectl get pods. So it is terminating right now. So it will take some time to be terminated. So no worry about this. So let's take a look at the pod life cycle. So the pod life cycle, there are different phases of a pod. Alright. So the first one is the pending, then running, succeeded, failed, unknown, and completed. So let's take a look at these phases, that what each of the phase means. So the pod has been accepted by Kubernetes system, but it is in the process and not running yet. So the pending means that it is accepted by the Kubernetes system, but it is in the process and not running yet. One or more of the container images are still downloading. All right. If the resources are not found, then it will search them and give you the success or failure message. Because the resources are not found yet, so it is still running, and it will give me a message if it is succeeded or failed. Now let's take a look at the running phase. So if the pod is successfully created in the node, then it will give me a running message. All the containers have been created. Alright, it means that it will give me a running message, or at least one container is still running or is in the process of starting or restarting. So it will still give me the running message. Succeeded. All the containers have successfully completed their required task and are going to be terminated and will not be restarted. Alright, so all the containers have successfully completed their task, and now they will be terminated and not be restarting again. So failed. All the containers in the pod have been terminated, and at least one container has terminated. Alright, so due to this one container termination, it will give me the failed message. The container either exited with non-zero status or was terminated by the system. So unknown. So the master does not know the state of the port. That's why it will give me the unknown message. So typically due to an error in a network or communicating with the host of the port, it will give me the unknown message. So now let's take a look at the completed phase. The port has run and completed the task, and there is no need to keep it running. Alright. So these are the port conditions. So let's take a look at these conditions. These are the possible types. Port schedules. Port scheduled. The master has scheduled a port to the node. Alright. So the port has been scheduled to a node. Ready. The port is created successfully and the container is also running in it. So that's why it is giving me a ready message. The container is also running in the port. All init containers have started successfully, and it will give me an initialized message. Alright. Unscheduled. The scheduler cannot schedule the port right now due to the lack of resources. So the next port condition is the container ready. All the containers are ready in the port. Alright. Apply the init file in the kubectl. Alright. Init container, you can get the condition of the port that first this happened and then this happened and then so on. Alright. So this is the thing that you need to that I have to written in the above previously. So I have written it here, so no problem. If you want to describe the init container, you will check this that you will get the condition that first this happened, first the initialized container created, and then the main container ran. Alright. After that, if you type kubectl describe port init container graph A5 conditions, it will only show you the conditions. It will not show you all the data in the terminal. Instead, it will only show you the processes that are currently running. So let me show you this one. So currently there is no init container. If I want to look at this kubefly.yaml. So now the container is created. If I write paste this, and as you can see that it is not initialized because it will take 30 seconds to be initialized. It is not ready, it is false, and it is port schedule. What it means port schedule? The master has scheduled a port to a node. So the master has scheduled a port, but the container is not initialized. So it will take 30 seconds. So if you take a look again, it will still give me this message. So let's take a look at this message. If we take a look at this one, kubectl describe port init container, it will give me this kind of message. Alright. So if you want to skip these messages and only want to show the take the data that initialized or port condition, if you want to only see the port conditions, you can simply write this message. Alright. So now it is showing me the initialized message because after 30 seconds the ports are initialized. So alright, so it is working fine. So I hope you like this video. If you liked it, then make sure to subscribe to my channel, and if you have any questions, then make sure to ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.